Okay, this is May 2017 HL paper, time zone 2, paper 1, question 5. In the following Argand diagram, the point A represents the complex number -1 plus 4i. Alright, so it has the coordinates -1, 4. Okay, and the point B represents the complex number -3, 0i. So this is -3, 0. The shape of ABCD is a square. So that means that this is 90 degrees, all four are 90 degrees, and the sides are all the same. Determine the complex numbers represented by the points C and D. What I'm going to do is I'm going to use a vector kind of approach, okay, and a bit of translation. So I noticed that the complex number from B to A, if I were to draw this as like kind of like a vector, this is the vector 2, 4. Which means that if I were to start this B at the origin, okay, I just move it parallel, this number is actually the number 2 plus 4i, the number. Right, so I hope you can see why, because, well, this distance here is 2 units, okay, and this distance here is 4 units. Okay, I'm going to move it to the origin because I'm going to use another fact, okay, and the fact is that the argument of the product of two numbers is the argument of one number plus the argument of the second number. Okay, and because of this, we can actually deduce that multiplying by minus I has the same effect as rotating a number by pi over 2 radians or 90 degrees, right, clockwise. Okay, why is that so? Well, because argument of minus I is actually negative pi over 2, okay, and that is a clockwise kind of angle. And so if I were to look at this particular number over here, translated to start from the origin, it has a certain argument, angle theta, and if I want to now rotate this number by 90 degrees, I'm actually going to take this angle theta and I'm going to subtract minus pi over 2, okay, and doing that has the same effect as like rotating the number to this point. Okay, so what I'm going to do now is I'm going to multiply 2 plus 4i with negative I, and that, based on this fact, will give me a number which is going to be 90 degrees like this, okay, and it would be how to find C, okay. So if I take 2 plus 4i, okay, and then multiply by negative I, I'll get negative 2i minus 4 of I squared, which is 4 minus 2i. And that's going to be this red line over here. So in other words, BC is actually 4 minus 2i as well, okay, because I've taken this and I've just translated it, okay, such that it starts from the origin. Okay, so the vector BC is actually 4 minus 2. Okay, and so we can deduce that C is represented by the number 1 minus 2i. What I need is to realize that this distance over here is negative 3, okay, right? And so if I were to move this, okay, because this is 4, right? So if I move it back by minus 3, I will get this distance here to be 1. The x coordinate is actually 1 unit. Then moving downwards, okay, there's no y coordinate for B. So when I take this and I shift backwards, I still move downwards by 2 units. Okay, so C can be represented by 1 minus 2i. Okay, how about D? Well, now that I know that C is 1 minus 2i, I also know, okay, that this vector CD, okay, has to be 2 and 4 as well. In other words, I'm moving 2 units to the right and 4 units up, so I can deduce that D is actually 1 then plus 2 units for the real part, and then I start with negative 2, but I need to add 4 units to it. So D is going to be 3 plus 2i. Okay, and that is the answer.